Have you ever noticed what happens when a small car and a heavy commercial truck both slam on their brakes at the exact same time? The truck needs a lot more road to come to a complete stop. Or think about the busy streets of Kampala. When a boda takes a sharp turn through heavy traffic, the rider has to physically lean into the corner to keep the bike from tipping over. We see the same forces at work on a massive scale at the Owen Falls Dam, where the pressure of rushing water is turned into the electricity that powers the country. All of these everyday moments are connected by the same principles. This diagram shows the two main pieces of the puzzle. The cube represents matter, which is anything that has weight and takes up space, like a desk or the air we breathe. The wave pushing it represents energy. Think of energy as the power needed to get things moving, like the effort required to pedal a bicycle up a steep hill. Physics is simply the study of how this matter and energy interact. While biology helps us understand living things like plants and animals, physics explains the non-living physical environment around us. It describes the forces that hold things up, pull things down, and keep everything in our world moving. To make sense of all these interactions, we divide physics into 5 main branches. This gives us a practical way to organize what we see in the natural world. First is mechanics, studying motion and forces. In this diagram, arrows show how a bicycle chain transfers pedaling force to the wheel. Next, heat, or thermodynamics. The diagram seamlessly morphs into a metal roof, showing wavy lines of heat transfer under the afternoon sun. The third branch is optics, the study of light. When you see a rainbow forming by a waterfall like Sippy Falls, you are seeing optics in action as sunlight splits into different colors. Then we have sound, which explores how physical vibrations travel in waves through the air. You experience this every time you hear the beat of a traditional drum. The final branch is electricity and magnetism. This covers everything from the flow of charges that allows a solar panel to charge your mobile phone to the magnetic fields we use to navigate with a compass. These 5 branches are essential for building the nation's future. Civil engineers rely on mechanics to construct stable bridges. Radiographers use optics to see inside the human body. And aviation pilots depend on physical laws to safely fly and land a plane at Entebbe. Knowing which branch of physics applies to a specific problem allows professionals to predict outcomes, control forces, and design safer infrastructure. Before you can build bridges or fly planes, you start in a specialized room designed specifically for conducting hands-on scientific experiments, the physics laboratory. Because you are working with real forces, you have to manage hazards. A hazard is anything that has the potential to cause harm. On the right side of this screen, you see what happens when a workspace is unsafe. Physics labs contain physical hazards, like heavy weights that can fall and live electrical wires, not just dangerous chemicals. This is why there are strict rules. As highlighted by the symbol on the door, the absolute first rule is that you never enter the laboratory without a teacher present to supervise the equipment. Once inside, there is no running or playing. Moving carelessly through the room makes it very easy to knock over delicate glass equipment or accidentally trigger one of those physical hazards. The laboratory is where you first interact directly with real, powerful forces. Maintaining strict personal discipline is the most reliable way to prevent a serious accident. That discipline extends to what you bring inside. Eating and drinking are strictly banned. Workbenches can hold hidden traces of chemicals, and placing your food on them makes it very easy to accidentally swallow something harmful. Drinks pose another major risk. As seen here, water spilling onto exposed wires can instantly cause a short circuit or a dangerous electrical shock. If an accident does happen, the protocol is simple. Tell the teacher immediately. Even if you only break a small, cheap glass beaker, it is critical to report it right away so the broken glass can be handled safely. Finally, always wash your hands before leaving the lab. This ensures that no tiny bits of dust or liquid you can't even see leave the room with you. By learning to spot physics in your daily environment and by practicing safe habits inside the lab, you are beginning a journey toward becoming a problem solver for Uganda's future. Keep your eyes open because physics is everywhere around you.